All right, enough talking about TensorFlow. Let's actually apply it. So first thing we need to do is actually install TensorFlow itself. So if you're using the Canopy package that I've recommended for use in this course, go ahead and open that up. And if you haven't already installed TensorFlow, now is the time to do that. To do that, we can just go to the Tools menu here and open up a Canopy command prompt. If you're using Anaconda or something else, just do it from there. Within Canopy, we're going to be using the pip command to install things. So we can use pip install TensorFlow. And I've already done this previously, so it's not actually going to do anything, but if that is your first time, it will go out and actually download and install that for you. Now, depending on your operating system and environment, you might need to use a different command than pip. It might be pip3 on some platforms, but you probably know what to do there if you've installed packages before. All right, with that, let's actually open up our notebook. Go to wherever you downloaded the course materials for this course, and you should find a tensorflow.ipynb file. Go ahead and double-click that. And sometimes it takes a couple of tries to get it to work right. Hopefully we'll get lucky here. You should get a browser that opens up, and it should look something like that. Again, if you got a browser error of some sort, just open it up a second time. Sometimes things just time out and needs a second chance. Okay, so let's actually dive in and actually play with TensorFlow, shall we? Now again, TensorFlow is kind of the hard way of doing things, but you know, it's good for you. It builds character. If you can get through this, then you'll find the rest of this course pretty easy, I think. So let's start by looking at that world's simplest TensorFlow application that we did in the slides in the previous lecture and go ahead and see how that works. So again, if we just click in this little code block here, we've already installed TensorFlow. All we need to do is import that, and we're going to call it TF. And as we did before, we're going to create an A variable that contains the number 1 initially, a B variable that contains the number 2, and create a graph called F that just adds those two variables together. We will then create a global variables initializer, create a session in TensorFlow, run the global variables initializer to actually put the initial values of 1 and 2 into A and B respectively, and actually evaluate that graph that we actually defined to add the two things together and print the results of that. So again, world's most complicated way of adding 1 and 2 together. Let's go ahead and hit Shift-Enter to actually execute that block. And it's actually spinning up TensorFlow and figuring out how to distribute 1 plus 2 across my entire system. And sure enough, the answer is 3. So TensorFlow is working. If you got some error there, then there's some installation issue you need to go back and deal with. Let's do something a little bit more interesting than adding 1 and 2 together. We'll do some actual handwriting recognition. Now this is going to be using something called the MNIST dataset, and if you've looked at other tutorials in the field of deep learning, you might be saying, oh God, not another MNIST example. But there's a reason people use this example so much. First of all, it's built right into TensorFlow, so it's very easy to use, and it's also very fun. You know, we're actually going to be doing handwriting recognition here. So we have this dataset that contains 70,000 handwriting samples of people writing the numbers 0 through 9, and our challenge is to predict which number each handwritten image represents, which is kind of a fun task. You know, it's like mimicking to some extent how your brain actually recognizes handwritten numbers. And some people's handwriting is pretty bad, so sometimes this can be a challenge. Let's talk about the nature of the data. So it's broken up into a training data set and a testing data set. And each image is a 28 by 28 image of grayscale pixels. Now for the purpose of this example, we're going to be starting things off a little bit simple. We're just going to treat each pixel as an individual input into a neural network, into a deep learning network. So we're just going to flatten each one of these images into a flat 1D array of 784 pixels. Okay, so we take the first 28 rows from the top of the image, stick the next 28 pixels from the next row, then stick on the next 28 pixels from the next row, and at the end of the day, we just have a list of 784 values that represent the grayscale value of each pixel of that 28 by 28 image. Okay, it'll make more sense when we look at some examples here. Let's start by loading that up. As I said, it's built into TensorFlow itself, so all we need to do is import tensorflow.examples.tutorials.mnist. We'll create a session now because we'll need that later, obviously. We're going to create an interactive session in TensorFlow, which makes it easier to work with TensorFlow within an iPython environment like we have here. This removes the need of actually explicitly creating a session and looping within it. We want to break up this work across multiple code blocks, so that's how we do that here with an interactive session. Finally, we'll just call read datasets to actually load up the MNIST dataset. And 1 hot equals true. What does that mean? So at the end of the day, this neural network is going to have 10 outputs, and each one of those output will represent basically some weight of how much it thinks that individual number represents the classification of that numerical image. So 1 hot means that if, for example, I have the number 0, I'm going to encode that as a binary pattern. So let's skip ahead a little bit here down here where I talk about it a little bit more. For example, the number 1 would be encoded as 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. So we have this 1D array of binary values 0 or 1, and where that 1 appears indicates what the actual label of that image is. So if I have an image of the number 1 that somebody wrote, I would encode that in one hot format as a array of 10 values where the value 1 appears in value 1. So remember, we start counting at 0 in Python world. So if it were the number 0, the 1 would be there. If it were the number 2, the number 1 would be there instead. So that's what one hot encoding means. It's just a more optimal way of doing classification that's more finely tuned to the output of our neural network. Okay, so let's talk about the shape of our data. We have a training data set of 55,000 images, and then a test data set of 10,000 images that we're going to use to evaluate the performance of our neural network by giving it data that it's never seen before and measuring how well it can predict the correct classification of each image. So we say that the shape of our training data is 55,000, 784. That means that we have 55,000 images, each with 784 data points within them. So again, 28 by 28 images, 28 times 28 is 784. So our input tensor shape is going to be 55,000 by 784. 55,000 images with 784 values on each image. The test data is just going to be the label data, so that will be of shape 55,010. Again, we have 55,000 input training data points, and we have our one hot encoding that is an array of 10 values, where wherever the number 1 appears represents the correct label. Okay, so more specifically here, when we talk about a shape of 55,010, that's going to be the shape of our training label data. Okay, so that's kind of what we're working toward while we're training the network. During the test phase itself, we only have 10,000 samples, so the shape of that test data would be 10,010 in that case. All right, let's take a look at our sample data here, just so we have more of an intuitive understanding of what we're up against. Very important to always understand your input data, because often there's going to be problems with your source data, outliers that you need to deal with, and you want to really understand at an intuitive level what you're up against here. So let's go ahead and display some samples here. By the way, I never actually ran this code block up here, so let's go up to code block 2 here and hit Shift-Enter to make sure that we actually read that data set in. Takes a little bit of time. There we go. All right, so that's all been imported successfully. What's going on here is we're going to create a little function called display_sample for a given input element. So when I say, for example, display_sample 1, 2, 3, 4, that means pick the 1,234th input sample from our training data set and display it to me. So what we're doing here is we're going to extract the label in one hot format for that particular sample of the training data. We will convert that to a human readable number by using the argmax function. All that does is say, take the array element with the largest value and display that array element's value back to me. So that's just a little quick way of converting one hot format back to a human readable digit. We will then reshape that 1D image. So remember, each value is just a flat value of 768 pixels. We take each row and just stick it next to each other. To actually visualize that as a two-dimensional image in the same way that your brain sees it, we're going to want to reshape that to a 28 by 28 2D array. And then we can use Python's built-in matplotlib library to actually display that as an image. So let's go ahead and hit that, Shift-Enter. And we can see that the training data sample 1, 2, 3, 4 actually corresponds to an image of someone drawing the number 9. Here's what the one hot input, what the one hot label data looks like there. You can see there's just a 1 in the final value that represents the value 9. And we reshaped that to 28 by 28 and displayed it as a grayscale image. So, it's not a bad example. That actually looks like a 9. So someone's handwriting was halfway decent there at least. So that's the kind of data that we're dealing with here. This is what a training data sample might look like. All we're getting as an input is this image flattened. Okay, it's actually going to be flattened and not a 2D image, along with the target label. So we know that this person intended to draw the number 9, and this is what it looked like. And we have 55,000 such samples with which we can train our neural network. Okay,